cool, we got there in the end. So, right, this one is on. So we're going to examine the AWS Security Token Service. We're going to determine when to use the token service. Information security, there are two common concepts: authentication or authorization. Auth being the process of verifying an identity, person, device, or application. Authorization being the process of deciding what the authenticated entity is allowed to do. The token service is a service that can issue a temporary credential to allow an authenticated entity. They have a policy associated that determines what resources the credentials can have access to. Using the temporary credentials when appropriate is best practice, and they can make the systems and application more secure. Benefits include not needing to store or have direct access to long-lived credentials. You don't need to rotate them regularly because they expire without being revoked. And you can make it easier to manage infrequent or irregular but required access requests. As well as being more secure, not needing to revoke the credentials, you can greatly reduce ongoing burden of managing access. Common use cases for temp credentials issued by STS include enabling or enforcing multi-factor authentication, automated processes such as build pipelines, software testing, and to allow third-party access through an API. You can also federate the identity. Most orgs will also manage user identities for their employees. Usually the identity is managed outside of AWS. Active Directory is an example of an identity store that is commonly used by many orgs. A naive approach to granting access from existing entities that are external to AWS is to replicate them in AWS and grant permissions to each individual entity. Orgs with existing complex entity structures, this can be time-consuming and ongoing admin burden and difficult to implement. There are two main ways that help orgs integrate with the existing identity provider. You have the IAM Identity Center, formerly named SSO, and the Security Assertion Markup Language based on 2.0 Federation. External entities. Often orgs keep separate identity stores for internal and external entities, and external entities, most commonly a customer that could also be a supplier of another entity. AWS provides two services to handle Auth-N and Auth-Z customer-facing apps. These are Cognito and Web Identity Federation. So we looked at those a second ago. If you use the STS Federation, it's possible to use the Security Token Service directly without any services mentioned above for giving permissions to customers and external entities. This approach comes with a lot of pitfalls and potential security risks. Right, introduction. Right, in this lab we're going to look at the command line and examine the Token Services API. In this step, connect to the EC2 instance. Got one called EC2 Inst STS Lab. And we're going to connect. AWS configure. Right, we need an access key. So hopefully it lets me copy today. And we need a secret key. Try that again without it skipping lines. Right, region name US West 2. Default output, leave empty. Right, so we do ls. So there's the things we've just done. Of course, now we do AWS STS get caller identity. Notice that the yarn ends in lab. This is the user that was created for you for doing this. So we can do STS get access key info access key. Oh, I didn't know that. Okay. Alright, so now to assume a role, we'll enter the following command: AWS STS assume role. Role on doesn't give me access. Sweet. Right, let's type it in. ARN AWS IAM 69 role session name that. Why didn't it like that? I copied it. Let's try again. There we go, that's better. To assume the role, it's given us credentials with an access key and a session token. Expires in another hour. So assume role requires that the yarn of the role returns temporary creds that have permission that match those of the role being assumed. So it contains an access key ID and a secret access key to be used with the role being assumed. These credentials are valid for an hour. And just the duration to be as little as 15 minutes and up to 12 hours. So now if we run that, we should see that my role has changed. No, sorry, we're still the lab user. Right, we create a bash helper function to assume a role and set environment variables. This helper function right, so now to use it we can just run assume role and set vars and then we can check our identity again. And now this time we've assumed the role role1 lab. This time you'll see that the yarn ends with the role1 lab instead of user lab, signifying that you are now using the identity of the role. To return to the lab, user credentials enter the following. We'll just unset the environment variables. We should be back to user, there we go. Right, if we want to view the details of the role that we assumed, we'll run AWS IAM get role name role1. Notice that the assume role policy document attribute this is an example of a resource-based policy. The policy is attached to the IAM role resource and it can grant or deny permissions. If we want to view the details of the lab users policy, we enter the following. IAM get policy on. You'll see a JSON response showing the details of the policy. If we want to see the policy of the lab user, then we enter the following. This allows us to assume a role, get users, get roles, get policies. Cool, alright, in this step we examine the API for the Security Token Service. We used it to assume a role. Right, did we assume the role? It's going off the cloud trail, making sure I did the call. There we go. Right, finally, simulating a federation with AWS STS. We're going to implement a simple web application that uses STS to assume a role. To create the new directory, change into it, and install Python dependencies. So just going to create a Flask web application. And then we're going to edit the app. Oh. Oh, here we are. We're going to create the file. That's what we'll do. Copy that. In a non-lab environment, the app secret key should be a long random string, but it doesn't matter for the lab. Define constants, add the following to the file. Right, the first constant defines the following: a list of prefixes known as an S3 bucket. the name of the bucket, and a dictionary containing 2 sets of hard-coded credentials. Each credential is associated with a role through the role key. The credentials and the bucket name are hard-coded for the lab for demonstration purposes. In a non-lab environment, the bucket name would be fetched from the config file or store. The credentials would either be looked up against a database or an API. To determine the function that the role assumes, the list objects in the S3 bucket add the following. So we're adding a function. Alright, notice that the client assume role call this code uses the role associated with the username before attempting to access the S3. To determine the HTTP route to the application, we need to add the following. So these are the endpoints that we've got. We've got a login and a dashboard. Save the file. Create a directory for the templates. Create the template file. Alright, run the Flask application in the terminal. We should be able to access it. Cool. Alright, log in with the first admin user. There we go, raw data file is denied. The application has assumed the role associated with admin1. The user named role1 and attempted to access both prefixes. The object under raw data is allowed and the object under the other prefix is denied. This is due to the policy attached to 1, allowing access to the raw data prefix only. Refresh and this time log in with admin2. There we go, and now we can get denied that one, we process that one. Right, so that's what we had to do. So we implemented, ran and used a simple Python web app to associate an IAM role to a hard-coded user credential. We used STS through the CLI to assume a role, and we'd examine the roles and policies. Right, so the check in this case is actually just did you create the Python file? We did. That should be it.